right, so now we're going to get into the vector analysis of how two simultaneous situations occur and how they affect each other and the overall motion of the object in question. In this case, we're going to be dealing only when they're going at perpendicular angles to each other, right angles. So let's take this scenario right here. The bird flies north at a velocity of 12.5 meters per second with the wind blowing westward at a velocity of 5 meters per second. What is the resultant velocity of the bird? Okay, so it's trying to go straight north at 12.5 meters per second, but it's getting pushed to the west at 5 meters per second. So it's going to be somewhere between north and west, but not either one. All right, so in order to understand this, we need to draw a vector graph to show what is going to happen. Okay, and this is a really good idea in solving problems so that you can see if you're drawing halfway decent, which I'm 50% capable of doing, to get a decent idea of what approximately the answer is going to be. So let's go ahead and draw north-south and east-west directions here. And we're being told that the bird is flying north at 12.5 meters per second. And then we have the wind blowing west at 5 meters per second. So we're going to try and keep this semi-proportional here so we get a decent idea as to how the angle is going to be figured out. Because we're going to need, since a vector involves both displacement and direction, the direction part is going to be pretty easy. It's going to be the displacement part is going to be pretty easy. The direction is what's going to be the challenge here. So what we're going to do with this is to extend the vectors opposite the other end of this vector. So this red vector is going to come over here and make sure it's a nice curvy line just so you can show that you're incapable of drawing a straight line. That's very important in teaching. My third grade teacher told me I could never be a teacher because I have horrible handwriting. I just laugh every time I think, look how poorly I'm doing. I'm trying to get the point across. We'll see about that. That jury's still out. So the 5 meters per second is going to be going down here. Now here's the key, and this is where some people make mistakes because a lot of times they'll not draw this. This is called a parallelogram. Right? Now wait a minute. Now that looks like a rectangle. Yes, a rectangle is a type of parallelogram where all the angles are 90 degrees. But if they're not 90 degrees, that becomes more what you or most people think of as a parallelogram. But this is a parallelogram. The opposite sides are parallel to each other. That's the definition of parallelogram. So anyway, so we are going to draw a point at the origin where these things occurred. Bird takes off, wind blows, and so they're trying to go in this direction here, but they end up going somewhere in between. Where it ends up going is the exact opposite side of the parallelogram. And now I'm going to cheat a little bit and make my own straight line out of it with the help of the smart board. And that's what we're trying to find right there. That length right there, which we will call C. I call it C because it's basically a hypotenuse here. It's a triangle with sides A, B, and C. I'll call this side here A, and I'll call this side here B. Or I could do the same thing with this triangle right here. I can call this side A, and I can call this side B, seeing how they're exactly the same thing. And it really doesn't make any difference which triangle you pick. However, having said that, you want to pick the triangle which the direction here is north, here is west, where the resultant is closest to. And this is why it's kind of important to draw a fairly proportional representation of what's going on here. And assuming that mine is correct, and man, is that a large assumption, you're going to want to pick the triangle in which this is closest to either north or west. Well, it's pretty obvious from this drawing that it's going to be north. So the triangle that we want to use then is this triangle right here, and this angle right here, which we'll call theta. And mathematicians and scientists really love Greek letters. This is the Greek letter theta. They love to use that for angles for whatever reason, because I don't think of the and as the same breath, so the is not going to make any sense. Anyway, so we also know that this is a right angle right here. So this is pretty easy to solve because this is I'm going to use the Pythagorean theorem to figure out what C is. And we know that C equals square root of A squared plus B squared. So this is going to be equal to the square root of 5 squared plus 12.5 squared. And if you type that into your calculator, which I've already done here, I get 13.5 meters per second. I'm trying to figure out, oh, yeah, that's supposed to be squares. So I'll have that fixed in the script. So that's supposed to be square root of 12.5 squared plus square root of 5.0 squared. So 13.5. meters per second is the resultant displacement. Now, the direction we know is going to be pretty close to north, but we can't say north. We know it's far away from west, so we can't call it west. And it's not exactly equal distance between north and west, so we can't call it northwest. That implies that to be 45 degrees. And that only occurs in isosceles right triangles, which ain't going to happen here. We know it's not. Because these two sides are not equal, A and B are not equal. So we get to use our vast skills on trigonometry, which I think, once you get SOHCAHTOA down for trigonometry to me is really, really easy compared to some of the other esoteric or in some cases, the way people think difficult math. This is not difficult. This is pretty easy stuff. So I want to find this angle, and I'm going to try to use the numbers that are given to me instead of coming with an answer. Not that I would ever make a mistake. Oh, of course not. But if I use this number in here and I got the wrong answer, and I use that in my SOHCAHTOA, then I'm going to get a wrong answer for my measurement. So I'm going to use the two given numbers right here. And so if you remember from your trigonometry, this is your angle. You have two legs and the hypotenuse. This is the hypotenuse right here. This is the leg adjacent to it. So we put a J for that. And this is the opposite leg to this angle. So we'll put op there. And the trigonometric function in SOHCAHTOA, opposite adjacent is right there. That's the tangent. The tangent of theta equals opposite over adjacent. Okay, so in this case, the opposite is 5. And we're not going to worry about the labels here, so we're just looking at a mathematical analysis here. And the denominator is 12.5. Okay, so we're not really trying to find the tangent. We already got the tangent. It's 5 divided by 12.5, whatever that is, which is 0.4, by the way. But I'm just showing off now. What we really want is theta. So we're going to go backwards in this problem. So that means on your calculator, you're going to hit second tangent, which will give you tan -1. and then you get a parenthesis on your calculator, and you type in 5 divided by 12.5, and then make sure, and particularly if you're in calculus, you're going to want to make sure that this is back in the degree mode. So you calculus people, and I would say it's all but maybe 4 or 5 people are in calculus as well as taking this, you need to make sure that you're checking before each class that you have the correct mode for your angles. So we hit the inverse tangent of 5 over 12.5, which I've done over here. And I get a value of 21.8 degrees. So this is 21.8 degrees. So theta is 21.8 degrees. But I have to say specifically what that means. What does 21.8 degrees mean? Well, it means that it would be north, except now it's shifted 21.8 degrees west of the north. So that's how we put it, west of north. This and this is my description of the resultant vector. 13.5 meters per second, 21.8 degrees west of north. Okay? So, keeping that in mind, I did these 3 practice problems. I'm not crazy about what the book has there, so I made my own problems. So, you go ahead and do those 3 problems right there, and let me know how it goes. And we'll talk next about non-perpendicular vectors. Take care.